interesting process that happens when we try to focus this, right? So when we react water with itself, it means we're reacting H2O with H2O. And that process is called ionization of water. So we'll have H2O, perhaps in liquid form, that is reacting with H2O in liquid form again, and it's actually a reversible reaction. It will form hydronium ions, H2O plus hydroxide ions, OH minus, right? So just say aqueous, right? So if you just remember our definition of what is an acid as well as what is a base, we can actually just try to break this into separate reactions. How do we do that? We can say, okay, let me leave space there. So we can say, okay, H2O can act. Remember, we did say that water, which is H2O, is an amphoretic substance. It means that it can either act as a base or as an acid. In the previous few lessons, right, we've spoken about that. So here it acts as an acid if it donates this proton, and then it will also form that OH minus. Or it can act as a base where it accepts this proton that was donated to form, and we call this protonation, to form this hydronium ion, right? So what is this telling me? This one is an acid and this one is a base. And then in the last few lessons, we also spoke about conjugate acid base pairs. So in this instant, this one is going to be a conjugate acid, because for it to move from H3O to H2O, it will have to donate a proton. So if you imagine if we had the reverse of this reaction, that would actually mean that this one behaves as it donates a proton, right? And this implies that our OH minus will actually be our conjugate. Sorry about the shadows. I'm taking this video at night. It's going to be a conjugate base, right? Cool. So another thing is that for this process, we can also calculate an equilibrium constant for it. So in the last few lessons, when we spoken about how do we actually calculate an equilibrium constant. So to calculate an equilibrium constant for this, would simply say Kw, so it will just be the product. So remember, if how do we find Kc? Remember, we defined it, and we said it's basically the ratio of our products, the concentration of our products over the concentration of our reactants. But in the for this equilibrium constant, we only include aqueous or gaseous substances, right? We don't include liquids. So that's why here we will only have the concentration of H3O plus as well as OH minus. We can't divide by this because these are in liquid form. So if it's either a liquid or a solid, we don't include it. So cool, right? And another interesting thing that they tell us is that at 25 degrees, at a temperature of 25 degrees centigrade, the concentration of H3O plus as well as H plus is actually equals to 1 multiplied by 10 to the power of minus 7. This is in mole per deci for cubic decimeters, right? Cool. But now we also know that they tell us that also at 25 degrees the concentration of H3 plus ion is equals to the concentration of OH ions, which we said it was 1 multiplied by 10 to the power of minus 7 mole per cubic decimeters. So it means we have both the concentration of OH as well as H3 plus. So this means we can actually calculate that Kw, and we can find it to be, let me just write this quickly. So we have 1 multiplied by 10 to the power of minus 7, 1 multiplied by 10 to the power of minus 7, right? And then there we are. So if you multiply the two, you'll actually get a value of 1 multiplied by 10 to the power of minus 40. Yeah, and basically that is it in terms of auto ionization of water.